All right, so did we do area in this chapter? Yeah, we did. Yeah, we've been doing areas, right? But the last lesson, we didn't really do areas. We just did the special right triangles. The reason they threw that in there. The reason that they threw special right triangles in there seems kind of like out of place because we've been doing area this whole chapter. But they did that so that you can do a little bit of this. Okay, there's going to be one example that we do that you're going to have to know about special right triangles in order to find the area of the thing that they want you to find. Okay, so we're going to do one more area, and I believe the next lesson, we're going to deal with circles. And yeah, we're going to do with area and circumference of a circle. Then the next chapter, chapter 8, is all about circles. The whole entire chapter is just about circles. It's like, how in the world can you have a whole chapter just about circles? Well, we do. And I kind of like it. It's one of my favorite chapters in geometry is the circles. Okay, so let's do a couple definitions. Actually, not a couple. Let's do 3. So if you said a couple, how many is that?
2.
Right. It's exactly 2. Some people say a couple to mean several, but a couple is actually 2. So we'll do several. We'll do 3. And let's talk about the radius. Kind of sounds like a circle, doesn't it? Right? You've learned a little bit about circles, haven't you? About the radius of a circle and that kind of thing. But we're going to talk about the radius of a what? A regular polygon. So first of all, before we even do this, let's define a regular polygon. We've defined it before. We've talked about it before. But somebody tell me what a regular polygon is. What's different about a regular polygon as opposed to like any general polygon? Anthony?
For a regular polygon, all the sides and angles are equal.
Very good. Okay, it's a polygon with all the sides and all the angles are equal to each other. Exactly right. Okay, so that's what we're talking about in this section right here. So everything has all the sides. Every polygon we're going to deal with has all the sides equal to each other and all the angles equal to each other, right? That's very, very helpful. So let's talk about the radius. Let's write these down. I wrote them down in my notes, so let's write them down. I think it's important. It's the segment. And we're going to draw these things out in a second, okay? But let's define them first, and then I'll draw it so you can see it. It's a segment that joins the center, and a vertex of the polygon. Okay, we'll draw a picture in a second demonstrating what the radius is, but that's what it is in words. Let's do another one that's really important. It's called the central angle. We're going to do a couple things with that today. All right, so it's the central angle. All right, it's the angle that's formed. The angle that's formed. I don't usually write out the definitions like this because it's in the book. You can always look at them. But I think it's important on these 3 to do that. Formed by 2 radii, just put it 2 radii. What is that? Radii. Yeah, it's the plural of radius. Okay, so if you have more, 2 is more than 1. So we put radii, 2 eyes next to each other. It's kind of weird. Drawn 2 consecutive vertices. You're probably looking at these words, you're like, I have no idea what all that means. But when you see the picture, it'll make sense. Okay? And then here's a weird word. You probably have never heard this one before. It's called apothome. You ever hear that word?
No.
Yeah, I kind of doubt it. It's not a very common word that we hear. Okay, but that's what we're going to do. Now, it's the perpendicular segment. Let's write this down. It's the perpendicular segment that joins the center. This is why I don't usually write out the definitions and the theorems and stuff, just because it takes so long. but that's all right. With a side of the polygon.
We literally waited till I got out.
All right, so there you go. So what we're going to do is I'm going to get me a polygon here, and I'm going to get me a regular polygon. So luckily this little program right here does regular polygons nice and easy. So, oops, click on that. Let's just do a 5-sided polygon on this one. Oops, why did it do so? What's that? There we go. I'll move it out of the way here in a sec. Okay. Now you can't see all the definitions, but you got them written down, so we'll just take a look. All right, let's take the first one, the radius. It says the segment that joins the center and the vertex of the polygon. So they don't really give you the definition of the center. Do they earlier in here? I think they talk about the center. Yeah, let's see. Do they talk about the center? They don't really say where the center is, but take a wild guess where the center of this thing is.
In the center of the,
Okay, it's probably about right in here somewhere. Can you agree? Looks about. It's probably like the same distance from all the vertices. Do you see that?
Yeah.
Yeah? Okay. So what is the radius? It says it's the segment that joins the center and a vertex of the polygon. All right, so that would be the radius. So let's do that in a different color. Yeah, you can go to any vertex. It doesn't make any difference. Okay, I could go to this one, this one, this one, this one, and this one. And so if this, what do you think is true? Now, this is true about a circle. So a radius on a circle doesn't matter. You start at the center of the circle, right? You go to anywhere on the edge of the circle, and that would be the radius. Doesn't matter like where on the circle you go. No, it doesn't matter. So right here, does it matter which vertex you go to?
No.
No.
not
It doesn't matter what vertex. Vertex was the key word there. Now, it does matter like where you go on the polygon, right? So that would not be the radius. Everybody follow me on that? Okay, that would not be the radius. But there is a place where if I start from the center and I go to the vertex, then that distance, let's try that again. I kind of scooched it off a little bit. Yeah, that would be the same for all the vertices, right? So if I took that from there to there, and then if I went from there to there, and if I kept on doing this, I'm not going to, I'll just do one more. You see that? What's true about all those yellow lines then? They're all going to be the same, okay? And that's what we know about a radius, but I'll just do that. So let's just write that in there. That would be the radius. So I'm just showing you on the picture what these definitions mean. And this is important that we do this because we're going to refer to these three things quite often when we do this lesson. So it's important that we do that. All right, what's the other one? Central angle. Let's do this. Let's draw another radius because of that definition. Because look at the definition of the central angle. It says the angle formed by two radii. So I have to have two, like I said, radii, okay? Two radiuses. All right, two radii. Drawn to consecutive vertices. What does that mean, consecutive? Right next to each other, right. So I'm not drawing from here to here, and then from here way up here, okay? Because this vertex and this vertex are not next to each other. Make sense? So here's one vertex. Here's another one that's right next to it. Do you see the angle that's formed by those two yellow lines? Okay. Well, we do have a triangle. That's true, but look at the angle itself. Okay. This angle right here is the what? Okay. All I'm doing is giving you the definition of this. I'm not asking what kind of an angle it is. So what's the angle? What's the definition? It's the what? What do we call this? The central angle. That's right. Okay. So that right there is called the central angle. I'll just put the angle symbol. Everybody with me? So that angle right there is a central angle. Now, let me ask you this. This is not really in the definition, but what if I went from here to here? Tell me something about this angle right there. That's also a central angle. And what do you think is true about the two central angles? They're going to be exactly the same. Everybody with me? I could keep doing this if I wanted to, couldn't I? Right? What if I asked you this? It's kind of off the beaten path a little bit, but it has to do with this. What if I asked you, and I didn't give you any other numbers, okay? All I gave you is what's in front of you. What if I asked you the measure of this angle right here? Could you find it?
Yeah. Well, you have to figure out how many. Well, it would add up to 360.
Okay, very good. Okay, so watch. From here all the way around to here would add up to 360. Agreed? And they're all the same. So how many are there? 1, 2, 3, 4. There's 5 sides. There's 5 central angles, right? So it would be what? 360 divided by 5.
72.
Is it 72? Okay, so each angle would be 72 degrees. All right, so that's kind of interesting, right? I didn't really give you any numbers on this at all, did I? But you could figure out what those central angles are. And again, that's something that you're going to have to do on the homeworks, okay, and on a quiz and test and all that kind of stuff. All right, so we kind of covered that part of it. There's actually a formula for this. It's a theorem. We'll get that in a second, but we kind of figured it out already, right?
Is that a recent one next to 72?
This is it's supposed to be, yeah. I didn't quite, 72 degrees. All right, what's the other word? Apothem. This is the weird one. Well, it's not weird.
It's not weird.
Yeah, it's not weird. It's just different. Okay, it's just a word that's a little bit different. All right, so let's start here. Now, what is it? It says it's the perpendicular segment that joins the center. So I'm going to start right here. I'm going to draw from the center as perpendicular to the side of the polygon. Okay, now I could go perpendicular here. I could go here, here, here. But since I've got all this stuff down here, I'm just going to take it right down to this. And it's perpendicular. So what does that tell you? It's a right angle. Okay, so that's right angle. So now, with that known, well, not necessarily. Okay, so, but watch. We do have a right triangle. Okay, again, this isn't really from the definition, but this is something that we could figure out. So take a look. Remember, the whole big angle right here was 72, correct? So what's this angle right here in the right triangle?
46.
36.
Why is it 36?
It's half of 72.
That's right, because if we take this perpendicular, it bisects that angle. We've had a theorem that said that a while back, all right? You can look that up, but it says if I have 72 degrees for that whole thing, if this is perpendicular and these two sides are equal to each other, it actually splits it up into two congruent triangles, which means this angle and this angle are going to be equal to each other. Does that make sense?
Yeah.
All right, so I just go 72 divided by 2, which is 36 degrees. So this angle, I'll just do that. This little purple angle right there, okay, that's 36 degrees. So I'll just put a 36 right there. So what do you think you can find now?
Yeah, the other.
This angle down here, couldn't you? Okay, so how could I find that?
Not the plus 36.
Plus?
Well, then subtract from the rate.
Yeah, but it's easier. You can do one math problem. Instead of doing two, 90 minus 36, okay? Now, you could do it the other way because this is 90 degrees, right? You could go 190 minus 180 minus 90, right? Which is 90, minus 36. But that's two math things you have to do, right? Just go 90 minus 36. Remember, the two acute angles of a right triangle are always complementary, which means they add up to 90 degrees, right? So this one and this one add up to 90. So how do I do that? I just go 90 minus 36. And what's that? 24? 54? What did I go 24? 54. So this right here would be 54 degrees. Look at that. You figured out all that stuff, all those numbers, without giving you any numbers, without giving you any angles or anything else, or even the lengths of the sides or anything. All I knew, what was really the only thing I knew? That I had a regular, how many sides is this? It's a pentagon. I had a regular pentagon. So if you can do that with a regular pentagon, you should be able to do that with a regular hexagon, an octagon, a decagon, any gon. Okay, you with me on that? Okay, so that's the kind of stuff that you're going to be doing in here. And we got all that just from those three definitions and just from stuff that we knew before, especially about this. Well, actually, we didn't even have to know anything about special right triangles on this, did we?
So the formula for finding out what the big angle would be just be 360 divided by however many.
Exactly right. And that's a great point because, is that the next?
That might be the next.
Yeah, it's basically the next theorem. Very good. All right. So to find the central angle, what do? We take 360 divided by how many sides you have, right? Because it's the same as the number of angles that you have. Okay. So if I have 5 sides, I got 5 central angles, right? Because if I drew one here, I would have 5 angles inside of there. All right. Everybody with me? Yeah. If you can figure that stuff out that we just did, the rest, it's not that big of a deal, except for the area. Okay, we're going to do area here in a second. Let's do a regular, and we've kind of done it already, but now that we kind of have an idea, let's do this. Let's do a regular octagon. So I'm going to make this 8 sides. Is that an 8? Yeah. There we go. And let's make this white. Just makes it a little bit easier to see. Let's make it just a little bit bigger. There you go. All right, so that's a regular, what? Octagon. Agreed? I'll tell you what, I just want to find where the center is. So I could do this, and I could do this. And boom, where's the center?
Right here.
Right there. Okay. Oops. Let's try this again. I got to click off of this. Because when it's selected, you can't write on top of it, and it goes away. So there, it's better. So now let's get rid of that. Let's get rid of that. Okay, we're good to go. So there's the center. Everybody good? Mm-hmm. So what I'm going to do is it says find the measure. So part A says find the central angle. And that's all they tell you. They just give you this picture, and you want to find the central angle. All right, so what do you think you're going to do? Okay, yeah, I would do that. You could draw it if you wanted to. Let's just draw it just for the fun of it, okay? Just so we can kind of visually see it. So right there and right there. So what are we trying to find? We're trying to find this, which is the central angle. Agreed? So how do we do that? Right, we take 360 and we divide it by how many angles we have, which is the same as the number of sides. It's an octagon, so there's 8 sides, so it's 360 divided by 8, and that comes out with 45 degrees. Okay. Now, they also ask for the base angles. Now, we didn't talk about this. We have talked about base angles before, but see that 54 right there? That's considered to be a base. Actually, yeah. Yep, that's the base angle, okay? It's right here. It's from the side to the radius. Everybody see that? That's considered to be a base angle. We good? Okay. So now we got to find the base angles. So part B says find the base angles. So that would be this one right here. And what else? This one right here. And what's true about both of these? They'd be exactly the same. Remember, this is only true about a regular octagon. It's not just any old octagon. You got to have all the sides and angles equal to each other for this to be true. Everybody understand that? Okay. So let's do it. We already figured out what this one was, didn't we? That was 45 degrees. So now how do I find these other two right here?
Oh, it doesn't like split in each like that.
What's that?
Yeah,
So if 45 like half of it, 45 divided by 2.
I wouldn't go 45 divided by 2. What can you do with these? Instead of finding what each of them are, you could find out what they. No, not that's what I said. Not what each of them or one of them are, but what. Yeah, 180 minus 45 will get you what both of these add up to be, and if they both add up to be that certain number, then how do you find each one? Then you just divide it by 2. Okay. So let's do the math over here. So we got 180. So that's supposed to be an 8. It's weird looking, but 45. Which is, what, 135? So it doesn't mean that this angle is 135. It means these two angles do what? Add up to 135. So what do we do with that 135 now? Right, and we only can divide by 2 if they're equal to each other. And they are equal to each other. Right, so we divide it by 2, and we get 67 and a half, right? 67, oops, points. 67, put my point too quick. Okay, 67.5 degrees, and that's what that angle is right there and right there. Pretty good, huh? Yeah. You could do that with all kinds. Now, they do give you a theorem. I'll just write it right here. I'm not going to write out the theorem this time. But the theorem says this. because it's really long. I'll just read it off to you. It says the radii of a regular, now it says an n-gon. What does that mean? It means any sided polygon, regular polygon. Okay, they just put n to mean it could be an octagon, a septagon, a decagon, a dodecagon, whatever. Okay, so it says the radii of a regular n-gon divides the polygon into n-congruent isosceles triangles. Okay, so what does that mean? Isosceles triangles. Look, this radii, or these two radii right here are the same, correct? So this and this are equal. That's why these two angles are equal, because they're opposite equal sides. See how it's all coming together? All that stuff we've learned in the past is all catching up with us, isn't it? All right, so we're using all that stuff we've learned earlier. So it's an isosceles triangle because two of the sides are equal, at least two of the sides are equal, and they form congruent central angles. All right, so these angles right here are central angles, and how do we find it? It says with a measure of, oops, there goes my pen again. I wish they wouldn't put those buttons on here. I guess some people do use these buttons. I'm not really sure what they're for, but I always got to make sure that my finger's not touching it. So what's the theorem then? To find the central angle. In order to find the central angle, which is this angle right here, what do? We take 360 divided by, well, in general though, the number of sides. And what do we use for the number of sides? N. Okay? All right, so that's basically what the theorem says. To find the central angle, this is to find the central angle, this one right here. What do? We take 360 divided by n. Well, we already knew that, didn't we? Because we looked at it, we kind of figured it out on our own, but that's what the theorem says. And they don't tell you the theorem until right then. All right. Well, they didn't give this to us. We found it. Okay? Yeah, so they didn't give us 45. We came up with it. All right? There's 8 sides, 360 divided by. Now, again, remember, it doesn't have to go straight down like this. I just did that to make it a little easier. I could have gone to here. Agreed? I got to, yeah. From here, I could do this, like this, like this, like this. Okay. Everybody see that? So each of these angles, see this angle right here? This one, this one, this one, this one, this one, this one, and this one. They're all 45 degrees. That's right. Okay? Yeah. Okay? And all these radii are also equal to each other. So what's true about every triangle in here? What about this triangle, this one, this one, this one, this one, this one, this one, this one? That's not the same. Let's give it better. Congruent. Congruent is the word we use for triangles, okay? So they're all congruent to each other. Which means, what's true about this angle and this angle? And this one? And they're all congruent. They're all the same. They're all equal, okay? Congruent's fine, right? So they're all equal to each other. Everybody got that? Okay, enough of that. Let's talk about what was our title of our lesson, by the way. We haven't even talked about area yet, have we? So let's do that now. So let's find the area of a regular polygon. Okay? 1, 2, 3, 4, 5. Let's go. I'm going to go back to a pentagon because that's the example they use in the book. So we'll use that. Let's make it just a little bit bigger so it's a little easier to draw on. Okay. All right. So I don't know where the center is. Probably about right. Oops. Probably about right in there. Actually, if I click on this, I wonder if it tells me. Yeah, it does. It gives me a dot right there where it tells me where the center is. So really, it's right there. All right. So there we go. I'm not going to go through the reasoning why the area is what it is. They do it in the book, but you guys were so disinterested in it yesterday. I figure I'm just going to now just give you the formula. All right, but it's in the book if you want to see why this is true. All right, so here's the area of a regular polygon. Okay, so regular polygon. Remember, this isn't true about every polygon, only if all the sides and angles are equal to each other, okay? So here it is. It's not that hard. It's 1/2, okay, times the apothem, right? We learned what the apothem was, times P, which is the perimeter. I don't think we've ever talked about that word this year, but you should know it from years past. What's the perimeter of this? Add up all the sides, exactly. Okay, it's the distance around. I always say perimeter is the distance around it, but that's how you find the distance around. Agreed? Add up all the sides. Now, I would have to be able to tell you what all the sides were, correct? Let's just do this. I should have drawn what the example was. Anyway, this was in my notes. So this would be a side. We've already discussed this already, but let me just do this quickly. Right there. What letter could I assign those two lines I just drew? What do we call that? R for radius, right? So that would be a radius. That would be a radius. And then you have this thing from the center perpendicular to one of the sides. And that is perpendicular. We call that an A, an apothem. All right? So if you know that stuff, you should be able to find this. So how do I find the perimeter, by the way? So like if each side was S for side, okay, how would I find the perimeter? On this one, I would go 5 times S, wouldn't I? Okay. Now, what if it was a number like 7? What would the perimeter be? 5 times 7, which is 35. Everybody's with me on that? Okay. And then you might have to do a little work to find the apothem. Okay, enough of that. Let's move that out of the way. And now let's do an octagon. So example 2. I'm doing example 2. And they want to find the area of a regular octagon with a certain side. So let's make this 8.
So what was the apothem for the one you just did?
What was it?
Yeah. What was like the?
It's from the center perpendicular to one of the sides.
So it's the area equals 1/2.
Whatever the apothem is. Okay. Sometimes they give you the apothem. Sometimes you got to figure out what the apothem is. Okay. So, well, it depends on what they give you. That's what we're going to do. That's why we're doing an example. Okay? All right. So let's take a look at this. So we've got an octagon. Let's see. So that would be, center would be right there. And what I'm going to do is I'm going to draw a radius. You could draw it to any of these vertices. It doesn't matter. I don't know. It just seems like it's a lot easier if you just draw it here. So I got this nice little straight up and down thing right there. Okay. And what I'm also going to draw is the apothem. All right. So, and they do give you some information and some numbers on here. They tell you what the apothem is. So they tell you the apothem is 12.1. They make this in centimeters. So I'll put a centimeter right there. I know it's kind of small, sorry. But it's 12.1 centimeters. And they tell you the length of the sides are 10 centimeters. Okay? And they ask you to find the perimeter. So this one's the easy one. The next example, a little bit tougher. Not much, but it's a little bit tougher. Okay, this one's pretty easy. Oh, so let's don't put perimeter. Let's put area. So what's the area equal to on a regular polygon? It's 1/2 the apothem times the perimeter. Okay? Well, what do we already know? We already know the apothem. So watch. I'm going to put 1/2 times A, which is 12.1, times the perimeter. Now, how do I find the perimeter?
10 times 8.
That's it. It's just 10 times 8. Pretty easy, isn't it? Why is it? Because there's 8 sides. All the sides are exactly the same, right? So you go 10 times 8. Or you just add 10 8 times. That would be silly, wouldn't it? That's why we learn multiplication, so we wouldn't have to do that. So it's 80. So all I do is put an 80 right there, and then throw all that at my calculator. 484. It is in centimeters, so my answer is centimeters squared. Now, look, I put P here. I shouldn't have done that. Let's put an A. All right, there we go. So the area is this right there. That's super easy, isn't it? 484 if you put that in the calculator. Okay. What? It's 1/2 times the apothem times the perimeter. Stuck the apothem in. Found the perimeter down here, right? Which is 80. Oh my gosh. Well, you're going to have to review your notes because we just finished talking about it.
You shouldn't have left.
Where did we get 80?
This is the apothem.
So where's the 8 coming from? The sides. On the sides.
You know, if you'd
Sam, it's an octagon.
stay awake, then maybe
The perimeter is the
look, the perimeter, this is 10. So this is 10, 10, 10, 10, 10, 10, 10.
Okay.
Right? So if you add them all up, it's 80. But don't add them up. There's 8 sides. Each one is 10, so it's 8 times 10. Right? Right there. 8 times 10 is 80. The apothem is from the center, perpendicular to one of the sides. Thanks for making me teach it all over again. But, okay. All right, one more example, then we'll be finished, okay? This is a hexagon. So let me draw it out. Now, you don't have to draw it out. I'll show you what I do. Because sometimes drawing these things, it's not the easiest thing in the world. Since I got this nice little computer program, it does make it kind of easy for me. Again, let's just make it a little bit bigger. About right there is good. Okay. So here's what we're going to do. I would find the center. So there's my dot right there. So there's my center. And I would make a radius. On this one, I'm going to make 2 radii. I'll show you why in a second. And then what's the other important thing? The who? The apothem. All right. So again, it's from the center and it's perpendicular to the opposite side. All right. So that's my apothem, this up and down one. These ones that are on a slant, those are my radii. So it just says find the area. So we're finding the area of a regular hexagon. So that's 1, 2, 3, 4, 5, 6. Yep, that's a hexagon. And what do they tell you? They tell you that the sides are 4, and that's it. That's the only thing they tell you. That the sides of this hexagon are 4, and it's in inches. So it's inches. So on this one, we're going to have to find the apothem, aren't we? All right? But let's write the area out. What's the area equal to? 1/2 times the area times the perimeter. I'm sorry, not the area. It's an A, but it's not area. What is it? It's the apothem. Okay. So is there anything that we know right off the bat? Yeah, we can find the perimeter. So off to the side, let's find perimeter. So it's 4 times, how many sides are there? 6. So what's the perimeter? It's 24. So what's the one thing that we need to find now to find the area? We got to find the apothem. Okay, so I'm just going to call that A for apothem. Now, how in the world are we going to do that? Well, we do know something. Watch. This thing, it comes down like this. What does it do? Where does it hit this opposite side? It hits perpendicular, so we get a right angle. But as far as the length of the side,
So it's going to be the same as the other one.
okay, so what is it going to be?
4. So that means that the apothem is 4.
No.
What?
No.
Oh, it's the
Say it.
The short.
Right. This side right here, that little side right there, from there to there, okay, that's going to be 2. Just remember what this does. It divides that triangle into 2 congruent triangles. So this side and this side are going to be the same of those 2 triangles. Okay? Well, not necessarily.
I want you to do 2.
What we're going to do is this. Now watch. What we're going to do has to do with the special right triangles. Okay? Now, if I would do this with a pentagon or something else, you would have to know some trigonometry. Remember, I've said that word before, haven't I, in here? Okay, you might have to know some trig. But the special right triangles is kind of trig, but that's what you can figure out. So let's do this. Let's figure out what that whole big angle is right there. Well, there's 6 sides, so this is our central angle, right? There's 6 sides, so how do I find this angle? That's right. 360 divided by 6, which is what? 60 degrees. Now watch this. If the whole thing is 60, what's this little one right in here? That's 30 degrees. And so what's this angle right here? No. I know you weren't. 60 degrees. So what kind of triangle is it? It's a 30, 60, 90. Okay? Now, what do we know on our as far as our sides are concerned? What do we know? We know the short side, don't we? We just know the short leg. Okay? So what is A as far as our special right triangles? It is. It's 2 square root of 3. Because remember, we just learned this yesterday. We learned that the long leg is equal to the square root of 3 times what? The short leg. Remember that? Okay, just had homework on it. All right? So A is the long leg, right? is the square root of 3 times the short leg. What's the short leg on this triangle?
2.
It's 2. But I don't write it square root of 3 times 2. How do I write it? 2
2
square root of 3. So now I know the apothem. So now I can put it into my area formula. So let's do it. So 1/2 times the apothem. What's the apothem? 2 square root of 3. I'm going to put that over 1 since I'm multiplying it by a fraction. Is that all right? Times the perimeter. I just found the perimeter earlier, which is what? Which is 24. I'll put that over 1 as well. Okay? Now let's simplify it. What's the easiest way to simplify this? Look what happens to the 2's.
You can divide the 24.
Well, you could do the 24, but it'd be a lot easier if you just did what?
Divide.
The 2's.
Yeah,
The 2's divide out. That'd be the easiest way to do it. You could say 2 goes into 24, which is 12, but then you got to go 12 times 2, right? When you just cancel out the 2's, you're just left with that 24. So we've got 24. What else is left? Square root of 3. So that's the area. Now, they're going to ask you to write it both ways. Did you see on the homework yesterday? They said write it in the exact form and the decimal form, okay?
I don't know how to do that. They're writing the exact form.
This is the exact form right here. Okay, when it says exact, that's what it means. It means keep the square root a square root. Don't put it into a calculator. All right, so this is the exact form. Now, why did I put a little squiggly equal sign? It's approximately equal to. So you throw it into your calculator. You can do that on your own, and that's 41.6. Now, what are our units for this thing? It's inches, so we're finding area. So this is inches what? Squared, and this is inches squared. So that's what they want. Now, listen to me. I said this yesterday, I believe. I am perfectly fine on a quiz or a test if you just leave it exact. All right? So you don't have to take the extra time, throw it into the calculator, and get a decimal approximation. All right? I am perfectly fine. Now, if you wrote it as a decimal and it's correct, it's fine. But it's just another thing you got to do that wastes time on a test. Okay? So I would just keep it like this. But you do have to simplify it. All right? You do have to cancel out the 2's. You got to make sure it's completely simplified. And then that would be fine right there for my answer. We good? I said about 2 seconds ago that if you wrote the decimal, then that would be fine as well. But I would prefer, okay, my preference is you just keep it 24 square root of 3. Right with me? Because, and why did I give that reason? Why do I prefer you just keep it like this?
This is the exact answer.
This is the exact answer, that's true, but it just takes extra time to get your calculator out, punch it in, get a number, right? And that's time you could have spent working on another problem. Not that approximations are a bad thing. They're a great thing because in the real world, in real life, we use the approximation. We wouldn't use the 24 square root of 3. We would use the approximation, okay? But in a high school geometry class, I'm fine if you just keep it like this. We good?
Yeah.
All right. So that was pretty interesting stuff, wasn't it? Yeah. So here's your homework. I know I gave you a lesson plan thing yesterday, but I'll write it down anyway, just in case somebody needs to refer to the video. It's 3:29, 3:30, and it's 5 to 12, and it's 14 to 22. All right, we got about 3 minutes, so I'm going to stop the recording, and I'll put the answers up to last night's homework just so you can check to see how you did. And I'll still have you turn it in, but then maybe we have time tomorrow, maybe. Let me see. Yeah, because I say I'm working class on 7.5B. So this is 7.5A. I'm going to give you a part B. So this is A. Okay?